Good afternoon and hello to everybody and a warm welcome from our side. It's a big pleasure to have everybody here in this webinar, this hopefully very nice and interesting TTI webinar, in which we are going to introduce some very nice and dedicated machining solutions from the DVS group. My name is Andreas Proswimmer. I'm the head of business development in the DVS group. I'm with the company since 3 years. And yeah, I did a lot of projects in the automotive business as well. And I got my colleague, our expert, Mr. Mark Hansen, with me today. And Mark, please have an introduction on your side.
Thank you, Andreas. Also, heartily welcome from my side. My name is Mark Hansen. I'm the head of sales of the Prevema Antriebstechnik GmbH, part of the DVS group. And yeah, looking forward and happy to show you some of our technologies today, and hope it's getting interesting. Thank you for joining.
Okay, so in this webinar today, we are going to have 4 chapters. In the first chapter, in the first slides, I'm going to introduce you the DVS company and our eDrive competence. And the chapter 2 and 3 will be done by my very experienced colleague, Mr. Mark Hansen. And last but not least, I'm going to give you a little summary. So who we are, the DVS company, we are a group of companies focused on 3 technologies, which is turning, gear cutting and grinding, and gear honing. So in German, that means DVS stands for Drehen, Verzahnen, Schleifen. So this is the abbreviation of our company. The headquarters is in Dietzenbach near Frankfurt. Internationally, worldwide, we have 1,300 people working for our group, and a turnover of around about 200 million per year. Yes, this slide might be a little bit overwhelming, but as I said, we are a big company. So some of you might know some of our companies and our brands, for example, Prevema, Pittler, Buderus Schleiftechnik. So they are very well-known brand names in the cutting machine tool industry. So this is our first business unit, Machine Tools and Automation, which is the foundation of our company. The second business unit, that's DVS Tools and Components, where we design and produce our own tools, for example, grinding wheels, honing rings, and all the tools for our skiving machines and honing machines. Last but not least, we have a very interesting business unit, which is called DVS Production. Here we manufacture parts for eDrives in series production. So this is very important for this presentation as well, because we are going to talk about the ring gear and the step pinion today. And in the DVS production, we are doing serious production of ring gears and step pinions. And I think you can imagine that we have learned some really important lessons in this endeavor. And yeah, in those lessons learned, we of course feedback in the processes and design of our machine tools. So yes, and in the eDrive industry, regarding gearboxes, we have 2 different basic designs of gearboxes, which is on the first hand the offset drive, which is on this slide. And we are very proud that we can provide some solutions for all the mission-critical work pieces on this gearbox, like the rotor shaft, ring gear, drive shaft, and the both intermediate parts, intermediate shaft, intermediate gear. So yeah, for all those projects, we have references in the market. And of course, same goes for the concentric drive. So in the concentric drive, there is the ring gear and the step pinion. And those 2 parts we are going to discuss in more detail in the next 2 chapters. There are 2 very special things. Regarding the ring gear, so it's a part which needs to be handled with care. So I think that's one of the bottom lines. So that's already a little teaser for our presentation, and the step pinion. So yeah, there is a feature which is called timing, which is one of the really special things at the step pinion, which you need to consider during the manufacturing process. And last but not least, all those parts, they have one thing in common, which is the following. So all the parts which I've shown to you on the 2 slides, so they are really mission critical regarding the NVH behavior of the eDrive gearbox. So that's really critical. And yeah, that's it from my side as a little introduction. Now I'm going to hand over to my colleague Mark Hansen. Please, Mark, the stage is yours.
Thank you very much, Andreas, for the introduction. And now I take over to give you an overview. And as Andreas mentioned before, we will focus more or less on 2 work pieces. The first work piece where we want to dive in is the step pinion. And we like to show you a scenario or a solution how to produce the step pinion. And we start in that case with the soft machining of the gear. So that means the skiving operation for the small gear at the Prevema synchroform machine. Followed by this process, it comes the hardening process, which is out of our portfolio. After hardening, it's necessary to have grinding, hard turning operation to eliminate the distortion from the heat treatment. This is done by Buderus on a ML3 235, I'm sorry. And finally, we have to finish also the gears, and this is done by gear honing at the Prevema Synchrofine. And last but not least, there is a washing process, and this is also not in the portfolio of the DVS solutions. As DVS, we are a system supplier and tool machine supplier. As I mentioned before, in that case, for the soft machining, we want to have a look on a Synchroform V from Prevema. And for hard machining, we have a look on the Buderus grinding machine, as well on the Prevema Synchrofine gear honing machine. Also integrated in our DVS group is the tool business, and therefore we can supply the whole system. That means the machine as well, the tooling. That includes also the design of tools, and therefore we are responsible from beginning to the end. There is no interference between the supplier of the tool and the machine, and that's the best solution for our partners on the worldwide market. We have a look on the solutions for the step pinion now, a little bit more detailed. At first, we will go through the soft machining, followed by hard fine machining and hard fine machining of the gear. Before we jump in the processes, it's more or less a must to have a look in the workpiece. On the page now, we show that what we're calling timing. Timing is nothing else than the relation between the 2 gears at the step pinion, and this relation fits only in one position. In many of the designs, it is not for all the step pinions on the market, but for many, and this make it necessary to have the processes from the beginning really under control and consider from first machining up to the final hard finishing the relation of the 2 gears. That's important, and later on I will come through some points where I can show the necessary. Soft machining of a step pinion. In first step, for sure, it is the typical turning operation in first and second clamping. And this is the first step where we have to consider high accuracy. regarding the timing. If you think about the picture before, there is a ball in a helical gear, and if the lengths are not okay, the ball will shifting according to the helix angle, and the timing is no more in the tolerance, or will be no more in tolerance. That's why important to take care from the first process on. So yeah, as I said, soft machining, typical wise, bore turning, outer turning, inner turning, clamping inside, and finish the outer diameters and the outer face of this part. Then we came to the gear machining. After the soft machining, we use this as references to clamp the part and locate the part accordingly. We can do a tip diameter returning. This is sometimes requested and recommendable for following processes. So then it's up to the customer to do it first the bigger gear by skiving, and in second the smaller gear by skiving. We can provide different solutions. One solution could be a machine which do the big gear on one spindle and the second gear on the second spindle. Also possible is a solution with two tools in one workpiece spindle. We call it tandem tool, and then we can produce the big gear and the small gear in one clamping on the same machine. Critical for the small gear is the interference to the big gear. This is shown on the picture on the right side. There is a small gap, and this limits us absolutely in the X-cross angle, what means not good cutting parameters, but we are able to use the skiving process also with a cross angle down to 7 degrees. Only for information, 20 degrees is the optimal cross angle for the skiving process. After soft machining, we have the heat treatment. As I said, not in our portfolio. So that means after heat treatment, we get the part back in our production line, and we will have at first hard finishing of this step pinion, hard finishing on Budero's iCompact. The iCompact do hard finishing in two operations. One operation is the hard turning, mostly used for the faces, and the grinding operation to finish the bore. And we use the clamping inside the gear, or this could be also possible related to customer demands that we can do the clamping on an external, on the OD of the bigger gear. Therefore, it's recommendable to do this pre-turning, as I mentioned, in the soft machining, to keep the best relation between the gears and the bores. Here we show, or here you can see some pictures out of the working area of the Budero's iCompact machine. On the left picture, it shows the hard turning, and on the right picture, it shows the bore grinding, ID grinding, and bore honing solution, which we have on the market for finishing this step pinion. Finally, after hard machining of faces and bore, the part needs to be finished in the gear accuracy. Therefore, we have hard machining of the gear. This hard machining of the gear will be done in a Prevema Synchrofine gear honing machine. Could be single spindle or double spindle machine. Both gears could be done by the honing process in two setups. First, the small or big gear up to the customer's demands. The honing process themselves is working, that what we say, with the X-cross angle up bigger than 3 degree absolutely safely. For the step pinion, we had to push solutions and create solutions that we are able to hone also with the limit X cross angle, which is a little bit lower than 3 degree. You will get all the advantages of the honing process. That means you will not have bias out of the process, which is coming at the grinding process, but you can do the bias by programming. There is no risk of grinding burn for the gear because the cutting speed is around 10 to 12 meters per second. Grinding burn is to evade from a cutting speed which is higher than 18 to 20 meter per second. We get a stronger surface, and the surface structure is better for the NVH and the end of line. That means less noises with the home parts. And altogether, with the corrections that we have to do in this step pinions, basically in all the parts which are related to the E-drive, there are very high and very small tolerances, high accuracy, small tolerances for the microgeometry of the gears. Here is once again and back what I had shown. We see the relation, the two small red balls between both gears. And now it's absolutely clear, if the soft turning has not been in the right accuracy, we will not have a good chance to clean up all the gears or all the tooth in a fine machining due the stock removal is getting too small. That's about the ring gears. Now I like to jump over to the second part. I'm sorry, that's about the step pinion, and I jump over to the ring gear solution out of the DVS group. Basically, there are two systems what we can see on the worldwide market how to handle this ring gears. Two systems means there are two process flows or workpiece flows for such a ring gear. In the beginning, green or soft machining, it is the same turning, gear cutting, and then it starts the different. And this is in a hardening process. One solution could be a case hardening, another solution could be the nitriding. In case of case hardening, face grinding and cylindrical grinding is necessary due case hardening has much higher distortions than the nitriding. And finally, we have to finish the gear by gear honing. In case of nitriding as a hardening process, the distortion is much smaller, and it's not necessary to have a face grinding and cylindrical grinding, and you can go through the internal gear honing. And now for sure everybody asks, oh, why we are not doing only nitriding? It looks much easier and less processes. Yes, both of this has plus and minuses, and scenario A is the process which has much lower costs in soft machining. This is related to the strong material which is necessary for the nitriding process. And the nitriding has, on the other hand, the disadvantage of the higher costs in soft machining due much lower lifetimes of the tools. But it could be avoided to do face grinding and cylindrical grinding in after heat treatment or after nitriding. So these are the two scenarios existing on the market. It's difficult to say which is more or less common. For today, we want to jump a little bit deeper into the scenario A. In the case hardening process, followed by grinding processes. So then the process flow will look like shown. We start with the fly cutting or skiving of external and internal gear. This is related to the different designs. Sometimes it's necessary to have also outer gears, which we are doing with the second process like fly cutting. After the soft machining, it's the same case hardening outside of the DVS portfolio. And then we get the parts back to a Buderos grinder and do the grinding operation, face and bore, grinding and hard turning. And finally, we have the gear honing, and after that, the parts can go through the washing line. The solution for the DVS group or machine solution from DVS side could be soft machining at Prevema or either a Pittler machine. This is related to number of workpieces, to the sizes, and also to the space floor. And hard fine machining will be done in that case at Buderos for the bores and the faces, and at the Prevema Synchrofine for finishing the gear. The soft machining in that case will be on a Prevema machine, followed by hard fine machining in the next step. Also for the ring gear, we have to talk about the workpiece themselves before we jump into the processes. And the ring gear has, from the shape, not the best conditions to clamp in the machine and to control deformations. That means if the clamping is too strong, we deform the part, or we give the part a form, and after releasing it flips back to the older form, or we can see the gripper jaws, for example, or the brackets from a clamping fixture later in the measuring reports. So therefore are different solutions existing. One solution shown here is working with a slight centering so that we avoid any deformation in the circle, and a face clamping with 10,000 Newton. This avoids the deformation radial less than 2 microns. Another solution could be a 6-drawer membrane jack, and with this 6-drawer membrane jack, it is less force necessary, clamping force necessary. We're working with 3,000 Newton meter, and with the 6-drawer, it's possible to have more or less equal pressure over the 360 degrees, so that we don't have much deformation. We're talking about 4 microns in that case. So now the Synchroform skiving machine for soft machining. It's a vertical machine in different options or in different configurations available. And the skiving process themselves is working with the rotation of both axes. That means workpiece and tool axis rotating at the same time. And with the synchronization given from the NC control and an axial feed rate, we can cut step by step the gear in through the tooth in through the ring, and then we get a ring gear. After soft machining, followed heat treatment, and then we get the parts back for hard machining, turning, milling, grinding on the Buderos BV235 machine. This machine is very good with the modular changing concept, including automation. You can implement different technologies, and this is done on what we are calling a technology platform, where we can place the technology modules according to the necessities of our customers. We try, or we can put this on a very small working area that's good and optimized for cycle times as well. It saves the floor space in the factories, which is nowadays also many times a question. And last but not least, also available different measuring and cleaning stations. If there's a like, we can install this in automation area so that measuring and cleaning could be done in parallel during the machine is working, and it causes no additional cycle time. The ring gear clamping system at the Buderus hard fine machining has the possibility to do orientation in the gear, and we can center in the gear, clamp on the face, and do the grinding of both faces as well the external diameter in one clamping. That shows the clamping solution, and in the clamping solution, the red marked areas is this, what will be done, as I said, in one clamping or at the Buderus machine. That means grinding of the first face, front face, the diameter, and here we have a look from the rear side, where we also do the grinding on the rear face. So one clamping and the part is finished in the grinding operation. After this grinding operation, the part goes through the hard fine machining of the gear. This is done by internal gear honing, and the internal gear honing uses similar system than the skiving and same system as the external gear honing. We need a X cross between the two axes, the axis of the workpiece and the axis of the tool. And then we need also the synchronization from NC. We have a radial feed rate and a small oscillation, and it takes around 60 seconds to clean up and the part and do all the corrections which are necessary and required for the final part quality. In clamping for the internal honing, we're using the same locating area as it is given from the grinding process in the Buderus machine, and we clamp also on the same diameter which is produced in one clamping at the Buderus machine. In combination with the orientation of the tooth, the centering in the Buderus machine at the pitch diameter, this is the best solution to get very good quality out of the honing machine. And if both processes are optimized, there should be no deformation and no deviations in the measuring report after hard machining. So one question was not given, but I want to talk about it, why we have to do hard finishing, in that case internal gear honing of the ring gear. This page shows on the left the result or the measuring report from a ring gear after heat treatment before honing, and the right picture shows the measuring report of the same gear after honing, and the required quality nowadays for all the components out of the e-drive is according to that what we see on the right side. Parts without hard finishing are no more usable for the e-drive nowadays. And hard finishing of internal gears is, in comparison with external gears, absolutely seldom, and was coming up in the car industry with the e-drive. And internal gear honing is in that case the best solution, because we can have the best offer or best solution in costs per piece for our customer. And we did different and many tests, and this shows a scenario what we had done 1 or 2 years ago. We did production on a ring gear, and we started with a diamond coated tool, and the tool costs had been at 80 euro cents, 0.8 euro. And we changed to the dressable tool and came down to 40 euro cent, what means we had half the costs. It was also interesting to compare it with the hard skiving, and we have all in our hand. That means also the production of skiving tools. We just did it, and the outcome was that we are much higher than with the diamond coated tool, and finally 4 times higher than with a dressable tool. And the dressable tool is more or less out of the state nowadays for the internal gear honing. Thank you, and I'd like to hand over to Andreas, who will give you a short summary about the pages before. Thanks.
So thank you, Mark. I think that was a very important and interesting presentation regarding the two workpieces, step pinion and ring gear. As a little summary, I think we can say step pinion and ring gear, they are really demanding, and yeah, they are workpieces which are critical in modern e-drives. What we have learned, yeah, the step pinion timing needs to be considered from the very first chip, even in soft machining. So I think that's one very important conclusion, besides all the other things we have learned. And regarding the ring gear, yeah, as I already said in the beginning, the ring gear is a very sensitive part which needs to be handled with care. And yeah, regarding the clamping, there are some important things to consider. And of course, for both parts, as Mark very nicely has explained, the hard finishing, the gear honing, the last step. So that's one very special thing. And I would say our DVS machining concepts, they solve two challenges. First of all, which is important for all of our customers, a cost-efficient machining process on the one hand, but on the other hand, at the same time, a machining process, the complete process chain, with a very high accuracy. Yeah, that's it from our side. Thanks for listening. Thanks for joining our webinar. It has been a great pleasure to have you here in this TTI webinar. I think it was a lot of information, and I guess there are some questions. And yeah, in the upcoming Q&A session directly now after our webinar, you are very welcome to raise your questions, and we are available the next 15 minutes. And afterwards, of course, if you have some individual questions, project-related questions, we are more than happy to answer your questions in the presentation. You will find our email contacts. Thank you, everybody.